Let us see this particular question. We have this function equals to square root of 9 minus x. So what we're going to do here right now, we're going to say, remember, this is the square root and this is 9 minus x. So this, we can have an answer. We said that domain, it's the input value that makes this function defined, and the range is the output value that makes that the output values of this function. So let's see briefly. So when we this value, for this thing to be defined, it is either equal to 0, we can have 0 here, or it is greater than 0. So what I mean is that you can have this function, and you can have this function whenever you put any value here, you can get 0, or it can be greater than 0. Let's see that briefly. Let's see something like this. So we have 9 minus x greater than or equal to 0. Now we're looking for the domain. So we have 9 minus x all square greater than or equals to 0. So we can square both sides. To eliminate this square root here, so we have 9 minus x. So this square will cancel this, and you have 9 minus x greater than or equal. Remember, the square root of 0 is 0. So we can say this, we can say 9. We can move this x to the other side, or we can say minus x. We'll move this 9 to the other side, it becomes a minus, and then when we divide both sides by a minus sign, this sign will change. So we have x less than or equal to 9. So what this actually means is that when we fix 9 into this function, you see the output will either give us 0, but this function cannot give us a negative number. It means that what I'm trying to say is that you can have a minus value here, say minus 2 or minus 3 or minus any number. You can have a minus value here, because if you have a minus value, it's going to give you a complex number or a math error, which means that the function is not defined. Remember, we say that domain is the input value you put that makes the function defined. So we can't have a negative number of this square root. We will only have a positive number, which is 0 and upward. So that's why we said this should be greater than or equal to 0 for this function to be defined. So now, what is the domain? Remember, I will say the domain are all input values that can make this function defined. So our input values is from negative infinity 9. The reason why we use this is because of this greater than or equal to, and then we use this symbol for infinity. Listen, we use this particular opening interval for infinity. So what do I mean by this? Now, if you put 9 here, you have 9 minus 9, you have 0, which means square root of 0 is 0, which means this function is defined. Now, we say negative infinity. Let's say we have this, maybe a number line. We have numbers. We have 1, 2, we have 3, we have 4, we have 5, we have 1, we have 2, we have 3, we have 4, and so on and so forth. So if we try minus 5 here, if you have minus 5, you have something like this, square root of 9 minus, let's say we try minus 5, we have minus 5, we have square root of 9, minus times minus plus, we have 5, say we have, this is 14, and if you put the square root of 14 on the calculator, you have a well-defined value. If you try another number, minus 3, it will still give you same thing. It will give you, that means any number from negative infinity, it will give you this function defined. Now, if you try 1 here, if you try 9 here, it will work. if you try 9, let's say you put 9 here, you have 9 minus 9, you have 0. So from this number up to 9, anything greater than 9, this function will not be defined. Let's say if we have something like this, we have something like if we have square root of 9 minus, let's say we try a number above 9. If we have 10, we have a negative number, which is minus 1. You can't get the answer. If you punch it on the calculator, you have math error, or you have math error, or this is a complex number. So if you punch it on your calculator, you have math error. So it is not well defined. So any number from minus negative infinity up till 9, the function will be defined. But anything above 9, this function will not be defined. And that's why we call it domain. And so that's why it is called domain. Let's see the range. Now, the range, is, we said the range are all output values. When you put in the values, the output that you get, that's the range. Now, let's see the range. The range, we have, when we put any number here, when we put any number up to negative infinity, we can have an output, the range, as from anything 0 to positive infinity. Remember, I said the reason why we're using this closed interval is because of the greater than or less than or equal to. That's why we're using this. And this open interval, we are using it because of this infinity sign. We use the open, and this thing, we use this symbol actually to denote it. So this way of representing these two things, the range and domain, is called the interval notation. It is called the interval notation. How do we know? Now, the range, I said, it's the output values. If you put 9 here, the output of this will be square root of 0, which is 0. So we can't have a negative number as the output. Like I said, we can't have a negative number as the output. We either have 0 and other numbers up to positive infinity. So we can have other numbers, but we can't have from -1. We can't have an answer of -1. Even if we put any value here, we can have -1. And that is what the range is. So I repeat again, the domain is the input values, that the values that you put into the function to see that the function is defined, while the range are the output values you get after putting in the domain. That's the output values you get. So share this video, like, and subscribe.